Okay, yesterday we looked at section 12.6 and the relationship between similar figures in 2 and 3 dimensions. And so today we're going to look at the fundamental theorem of similarity. If two figures are similar with a ratio of similitude k, then corresponding angle measures are congruent. Grab my non-working pen again. So this is like, if you have two similar triangles, let's say we're just doing equilateral triangles. Okay. So if these two triangles are both equilateral, then their corresponding angles are congruent. They're both, in order for the triangles to be equilateral, they have to have 60-degree angles. Then the corresponding lengths and perimeters are such that the perimeter of the larger divided by the perimeter of the smaller is equal to k, the ratio of similitude. So we saw that yesterday. And then the corresponding areas and surface areas are such that the area of the larger divided by the area of the smaller is equal to k squared. And then the volume k cubed. So we'll look at another example of this here. So remember we looked at what is the best deal at Vitale's for pizza. And the way we looked at it before was looking at the cost per square inch for pizza. So we'd find the area of the pizza, and then we would calculate cost per square inch and compare. We could also do this using ratio of similitude. So let's say we were going to compare the 14-inch and the 9-inch pizzas. So you might think that you can just make a ratio here. It's like, okay, if we know the 14-inch pizza is $15.90, what can we say about the 9-inch pizza? And you might think, oh, I can just set up a simple ratio like this, where I can find X, and X would be what the 9-inch pizza would cost if it was at the same the same cost equivalency as the 14-inch pizza. But this will not work, because because cost is a function of area in this case, and these are diameters which are one-dimensional. So it's taking a one-dimensional thing and crossing it over to a two-dimensional thing. So let me try to explain a bit more. Let's just look at our k value here would be 14 over 9. So 1.5 repeating, 1 5/9, however you want to write it. And so what that means is if you were to look at your 9-inch pizza, the cost, and then project it, what would it cost at the same rate? So take the cost of your 9-inch pizza, and because it's area, and area is k squared, we need to multiply by our answer squared. And so we get $27.32. So if I take $11.29, the cost of the 9-inch pizza, I multiply it by k squared, I get $27.32. And what that means is that at the rate the 14-inch pizza costs, at the rate that the 9-inch pizza costs, the 14-inch pizza should cost $27.32. And it doesn't, obviously, which means the 14-inch pizza is a much better deal. But let's go back and take a look at cost per square inch just a minute to verify this. So the area of the 9-inch pizza is pi 4.5 squared. And so cost is 11.29, so cost, and then we're looking at the square inches of pizza. Okay, gives me a cost of about 18 cents per square inch. Now the 14-inch pizza would be pi 7 squared. So let's do cost 1590 divided by all right, and so you get the 14-inch pizza has a cost of about 10 cents per square inch. So you can see that the 9-inch pizza is almost double the cost per square inch. And that's why this $27, this is what this is saying, is that if the 14-inch pizza was charged at the same cost per square inch as the 9-inch pizza, it would cost $27.32. So if we were to take 49 times pi, the area of my 14-inch pizza, and multiply it by this cost per square inch of the 9-inch pizza, we end up with $27.32. That's this number here. So this number says at the 9-inch cost, a 14-inch pizza would cost $27. And in reality, it costs 15. So you can see how drastically better a deal it is to buy the 14-inch pizza than the 9-inch pizza. So you can use ratio of similitude in conjunction or in replacement of cost per square inch if you wanted to. So like if we wanted to say what's the better deal, the 12-inch pizza or the 14-inch pizza, we could say, okay, well, K would be 14 over 12. So that's 1 1/6. All right. And so if I took my 12-inch pizza, 1260, and I multiply it by K squared, what do I get? So 12.6 times K squared, I get $17.15. So that's saying if my 14-inch pizza was sold at the cost that they're charging per square inch for the 12-inch pizza, my 14-inch pizza would cost $17.15. And they charge $15.90. So again, that shows that the 14-inch pizza is a better deal than the 12-inch pizza. But it's not as drastic a difference, right? $17.15 or $15.90 is a lot different than $27.32 compared to $15.90, right? So it means that the 12-inch pizza is a lot more moderately priced in comparison to the 14-inch pizza than the 9-inch was. So if you want to see the most dramatic, I think the most dramatic is going to be if we take the 16-inch pizza and compare it to the 9. So 16 over 9 is 1.7 repeating. So 1 7/9. So that's our K value. So if we take 1129 times K squared, what do we get? 35.68. So what that's saying is that if my 16-inch pizza was sold at the same cost per square inch as my 9-inch pizza, it should cost $35.68, but only costs $18.40. So dramatically different. So almost half, right? So the cost per square inches of the 16-inch is almost half. So it's probably pretty close to the 14-inch, actually. So in this way, you can compare, because these are similar figures, right? Two different size pizzas are similar figures. And, well, they don't have angles technically, but you know what I'm saying. And so we can look at their areas and costs this way. So the big thing to avoid, though, is to not, sorry, let me reword that. When students make mistakes, it's often that they set up this kind of basic proportion like this, and they neglect that because it's area, they have to square the K value. So if we don't square the K value, then we don't come up with the same answer when we do cost per square inch. So it is an area problem. You have to use K value. Okay, so your assignment, you need to read the section in the book, 12.7. It's a very difficult concept. You need to read the book. And then there's a 12.7 worksheet I'll post. But feel free to ask questions. This is not easy stuff.